Hello again.
Nice to meet all of you.
Hello, everybody.
Hey, Rich.
Hey guys.
Hello.
Max, shall we give a couple of more minutes for people to join, or do you want me to start now?
I think wait maybe one more minute and then we can definitely start. I would like to announce what I put into the chat really quick as well, in case anyone missed that we migrated from the OneNote to Engineering Hub. But I
Yes,
think
sir. Sounds good.
But I also think we can get started and then we can just see as go. So just a really quick announcement for everyone who might have missed that. I migrated our OneNote that we had in the AHGC Real Europe engineering channel so far, that had all of the old text sessions, all of the links to the resources. I migrated that to Engineering Hub. So this is now in our official Engineering Hub presence. I will put the link here. It's the short link is aka.ms/agc-prague/text sessions. I will put that into the chat, and everyone can feel free to take a look there. You see all of the old text sessions, the recordings. So in case you missed any text sessions or want to take a look at text sessions that have been happening before you joined, feel free to take a look there. Everything is there, and yeah, there you find all the information. And that's it already from my side. I don't want to take too much time. Partha, thank you again for taking the time. This was super interesting last time, and I'm happy to get to know more about that in the second part today.
Thanks, Max. I think consolidating it in a central location will be super useful. So thanks for doing that. All right. So let me get started, I suppose. I'll share my screen. I think we'll just wrap up the previous kata, and then we can. Yeah, I think we were pretty much done with this. I think we had a couple of steps remaining. Maybe just so as a recap, right? What we had done was we had implemented a bowling game and then divided up into these 5 test cases. We went all the way up till the first pair, and essentially this introduced a bunch of refactoring that we had to do to realign our the design that we did, right? So we went in a particular direction. It turned out to be too simple for one of the tests, so we changed the responsibilities, re-assigned the responsibilities, and sort of make it look a bit more readable, right? So just let's wrap up the next 2 test cases. I think we're very close to getting this done. So the fact public void test on strike, right? And the strike is I'm sorry, I think yeah, the strike is also very simple. So g dot roll 10 and then g dot roll, let's say just any random score. So the whole idea is that here roll many, this will be, remember the roll is 1 full frame. So this is 2 rolls, 3, 4 rolls. So you have 16 rolls remaining, and then you score is 0 here. You're just sending the rest into the gutter. So somebody can tell me the score on this. Should be, so the score is going to be 10 plus bonus 17 plus the next 2 rolls, which is 3 and 4 again, so 24. Right. So this is, and then let's add a comment here, right? This is a strike. Okay, so we added the test case, the bare minimum test case. This fails, so clearly we can't proceed ahead. The design looks more or less open closed. Now you can see, right? We don't have to mess around with any of the thing. We can just add a else case here, right? So else if let's say roles, current role equal to 10. Then what do you get is score plus equals 10 plus roles plus 1. This is the next frame, bonus number 1 and bonus number 2. And then we have frame index. Right, I think this is frame index. Sorry. Let's see. Okay, so what's going on wrong? This is frame index again. All right, so this looks fairly okay. Some minor refactoring, right? So this typically having this kind of conditions without the thing is you lose context of this like 4 days, 5 days down the line, right? So you will forget what you were trying to do here. So typically it's a good idea to just rename it as is not stroke, strike. I wouldn't want a stroke. Then extract method. This is going to be strike p bonus. You typically don't want to put the score here. Yeah, that's I think that's pretty much it. Maybe just refactor this out as well. Roll strike so that you get rid of the comment here. So all the comments you can essentially use your name of the variables, name of the functions, and that you can make them readable instead of having comments all over the place. The problem with comments is that they don't participate in refactoring. So if I rename this, right, the comment is just going to get carried along with it, right? So the comment is opaque to your tool set. So this is the role. So unless it's an exceptional case, like you want to give attribution to something, or you want to say, hey, you know what, this is the reason why I did it. This is very non-obvious. You're explaining to the next guy. Comments are typically not really very useful simply because they get out of date pretty quickly. Right, and that's pretty much it. I think let's just do one other test case, which will be the perfect game. There is an obvious question that should come up in people's mind after this. So feel free to shoot. So test. Perfect game. So roll many. Perfect game is going to be, anybody wants to tell me what the perfect game can be, should be? Roll many, how many? So all the 10 frames plus you get 2 bonuses where you do 10, 10. So that'll be 12. And then you get a 10 for each. And then the score is going to be what? Somebody please tell me.
It's a 300.
Awesome. Somebody has been playing bowling quite a lot of late, I suppose.
But I've never gotten a 300 though, I can tell you that.
Okay, fine. You got a 300 here. So looks like, yeah, I mean, so that's usually the case, right? So when you're refactoring, that there'll come a point where you have to change a fair bit of things, and after that it just becomes easy. Things just fall into place, right? So it's reasonable code quality. Your code coverage, we haven't tried for any code coverage stuff, but you can see, right, pretty much all the lines are covered. There is no line that is dash. There'll be a dash if there's a code is not covered. So code coverage is a side effect of the way you're doing it, right? The high test coverage, obviously you've driven it through a behavior. You've gone the behavior first. Then you've used your tool, so the tool is always constantly checking and looking out for you. So those are essentially some of the benefits that you get out of a test-driven development experience, right? Now the $1 million question should be, okay, so the $1 million question should be, this is all good for a 1-pager and 50 lines of code, right? So does this process scale, right? Can it be used in production? Does it scale across a team of 15, 20, maybe more, right? And or this is only good for pet projects and small projects of this type. The answer is it scales, right? Here are some sample projects. The whole idea is that you can see this is domain independent. ADO release management is essentially the product that I built last time before I left, and you guys, we already use it as Azure DevOps pipeline, right? Release pipelines. This has a lot of TDDs components. At least the version 1 had. I don't know since then. This was in back in early 2015. I don't know what's the deal with it right now. Maybe I should go check it. This has a lot of TDD in the exact manner that I described, right? A lot of C#. There wasn't much of a JavaScript, but nonetheless a lot of C# stuff. TypeScript, C# and TypeScript, bunch of projects. These are my client projects. They're under NDA, but I can, walk us through it. Like if you guys are interested, we can have a closed session, and then, I can't record it that simply because it's under NDA, but I'm happy to walk us through, how the same process applies for TypeScript. There are similar sort of tools, right? If you guys need this, I think for Visual Studio at least we have the tool, which is live unit testing that is accessible to all of us. But TypeScript and JavaScript have a separate tool for this. I can't recall the name right now. This is a very similar tool. I think it's, well, I don't want to take a guess. So I'm pretty sure the organization can help sponsor this tool, right? If we need it, requires licensing and things like that. This is another project, right? This is the whole deal with this is once I had the idea, right? Like, so if I am, and this was well before this tool that you see here that monitors your tests and shows your coverage well before, while you're doing it, right? So why can't somebody just build a plugin that just, you in the olden days, you had to manually type code, run the tests and see the coverage, right? And the coverage wasn't shown. So why can't we just have a Visual Studio package that does that for you? So I built it in the sabbatical, like in the first 5 months of the sabbatical. And the state at which it reached was that I could use this to test drive this itself. So this is like a self dog food. Now, this one is fully test driven. This is like a fairly complex piece of code, right? You can, for example, the engine, if you see, right? This has a fairly you guys can take a look at this, right? So this essentially ends up injecting code into your Visual Studio, into the IL assemblies, and instruments this, then collects the data so that's how you get line by line coverage. So you guys can feel free to check it out, how, and this is all fully test driven in the manner that I described, right? These are like part of the project, but after a while I got bored and gave up, right? Now this one, again, you can see the domain, right? This is like just a bunch of fun, this thing, right? This is another domain where this is the starting point of a 5150, like those DOS machine emulators. Only old timers like me, Rick and others will remember this. This used to be the ones where I used to play DOS video games. The state where this is in is that the CPU boots up, CPU is able to do a self-test, and it's just about to boot up the PIC, right? Programmable interrupt controller, and I just left it after that. But again, right, this is completely test driven in the manner that I showed you. This is again done in Rust. This is done in PowerShell, right? Again, this is also test driven. I can quickly take you guys through this maybe. So the same process. This is like it's not a very large component, but this was one of my open source projects. This requires a bit of a, this is where parsing some of the XML stuff that requires the rest of the pipeline builds upon. So you can just see, right? This is fully test driven in the manner that I just described here, right? So these are the examples. Feel free to play them out. If you guys have examples that you would want to try out, remember at work, you're better off getting your EM approval simply because some of these things have a learning curve. We don't want to waste time, spend a lot of time and figure out you haven't made any progress. But in your pet projects, right, if you want to try it out, by all means, pull me in. I'm happy to kind of I also got the feedback from Yenrik saying that, hey, it might be a better idea to show people some real world projects that they're working on. And we'll have a session for that as well, right? Somewhere down the line, right? We have time for this, and we will get to real world refactoring and test driven legacy code refactoring, a bunch of this stuff. Now, what are the salient features, right? So this connects back to your the picture that I painted earlier. So this is language and domain agnostic. It becomes test driven design. It's no longer development. So your design starts emerging, right? You start emerging the design purely based on the way you're driving your behaviors. Each unit test is 3, 4, 5 around that ish line of code. testing a facet of responsibility, because that's what you're starting out with. Remember, you're not typing a line of code without knowing what that line of code is going to be doing, right? Clear separation into unit and platform tests. So there is no way you can do this experience by running, by when you have like a test that takes 3 minutes to run. There is no way you can run this process. So you will necessarily have to break it down into platform test that is long running and short running, of the order of milliseconds, right? 3 lines of code, so it just takes milliseconds to run. One test double at most, and test double is typically short-lived in-memory objects. Nearly 0 mocks. All the sample projects that I've shown have barely any mocks. Sometimes it's necessary, especially for legacy code refactoring. We'll come to that in one of the talks. Like you saw, right? High code coverage, low second-memory complexities. These are just the side effects, right? Right. You're not necessarily shooting for this, but at the same time, this is a side effect of the way you're doing things. So that's essentially brief tour of the, you can think of it as a staged, right? You can figure out where you are, and then you can kind of take steps to see, what you need to do to get to the next step, next level of skill. All right, so key takeaways: keep track of the class of tests you're writing. So this awareness will at least let you know, saying that, hey, maybe I'm overdoing on the acceptance, maybe I'm overdoing on the unit, maybe I'm overdoing on the platform, right? Then this is very critical, right? Build a mental repository of decoupling techniques, starting with the 4, but as you do more and more, as you try to push your code more into unit tests, you will figure out. So eventually you will have, like, in get into a situation, you can get into any situation, kind of break it down. Right. So start with 4 from this deck. Keep track of where you are in the 7 levels, plus lots of practice, right? And a pet project or an open source project. And if you're looking for ideas, I'm happy to work with you. They are the great place to build your skill, right? And then developer testing principles are language, framework, tool, domain agnostic, right? So as long as software 1.0 is there, this will be applicable, right? No matter what your language, no matter what cloud, no matter what tool, no matter what domain, does not matter, right? The key thing here is you're thinking in terms of the consumer and client, right? So this is what we've been doing here. What do we want G to do, right? Not how will G get implemented. The how will G get implemented will get done. It'll come out eventually, right? It'll emerge. But once you nail this, once you nail the behavior of G, right, it becomes very easy to get the minimal, best looking implementation of G that satisfies these constraints. And these are the constraints that you want, which is the behavior, right? And these are essentially the references. There are not many. This is all knowledge that is out here. All right, so we'll move on from this. This was. And we will get into the next session. So this one will be a pretty quick session. And by that I mean 30 minutes, maybe 35. So this will, I think Andre made the comment in the first talk saying that, hey, solid principles could be generic at times. There are specific principles. So these are the specific principles we'll take a look in this session, right? And these are something actionable that you can get down and start doing, or when you get down into a code review, we can start straight away start applying, right? These are very less subjective, and these are more objective than they are subjective. I should probably wait. Any questions so far? I guess not. So today the talk is going to be focused on primarily these two sides. So we covered TDD. Pair programming is something that we'll cover later, but I think these are the core 4 extreme programming practices that is essentially the engine of your development team, right? This is the third talk. Just to be clear, right? As much as I love these topics, I think these topics I can geek out of them for hours at an end. And if I have somebody geeking out with me, then time doesn't matter anymore. But it's because people, it's because we've found hard. We've not been able to find somebody who's volunteering. That's why I'm presenting, right? So don't think that I'm enjoying myself boring you guys with these topics. But the deal is, right, I think going forward, we have one session coming up from Thomas and another from Radek in the next month. And also in the next month, time permitting, if all goes well, I'd like to cover functional programming 1 and 2. Right, this will from the real basics. This is real fun. people that like math, this will be totally funky for you guys. All right, the warning, right? You're not expected to try this out, so don't think that you have to try them out at work. Certainly get your EM approval, right? But remember that these also have, some of these have learning curves, so it's pretty easy to start, getting into your work and then all of a sudden figuring out that, hey, the week has gone by and I haven't done anything. Right, but definitely try them out in pet projects, right? This is a great way to build skill, right? And try them out. Get your EM approval, please. Otherwise, you don't want me to be this guy in the middle, right? Getting beaten up by your Prague EMs. Anybody know what this is?
It's a circular galaxy.
Yes. Bit more context. Okay, this is essentially the cover picture of Bob Martin's clean code, and most of what I present, like about 60% is in some form or the other from his books, his content, his talks. The other 40% is from various sources, including what I have done in the past as well, right? But Clean Code is an awesome book. Clean Code is definitely worth. This is one of my mentors said that this is one of the life-changing books, right? Clean Code, then the C Programming by Brian Cunningham. There are a few other books like this, right? TDD by Kent Beck. These are essentially the life-changing. This is what makes you fall in love with software again and again and again, right? Definitely check it out. But here, Bob Martin says that this galaxy is the Sombrero galaxy. This is about like 20, 30, 40 light years from us. He says in the book that this is a supernova that went on in the middle of the galaxy, then just blasted the galaxy wide open. This is like 100 light year old, 100 light year wide. So you can think this is like 50 light years. So this will probably be about 30, 35 light years whole, 60 light year hole in the middle of the galaxy by, this is a supermassive black hole. In the center. So he was saying, but I couldn't find references to that. But he was saying like it's pretty funky that one supernova just blasted the entire galaxy into the shape. It's pretty scary. But let's get to the agenda, right? So here we'll talk about certain metrics, certain fairly objective metrics around software design. Why is there design rot, and what exactly is design rot? What are the smells? So when can you detect that your design? And when I say design, I mean design and code interchangeably, right? Code is the expression of design. Then there are two tenets of software design, which is dry and Yagni. This dry and Yagni are very intimately connected to solid. Then there's the concept of merciless refactoring. These are all real terms. I have not made them up. Somebody else has made them up, so I'm using it. And somebody very famous has made them up, so a lot of people use it. Merciless refactoring is an extreme programming term. It's one of the 12 extreme programming practices. We'll come to this. Then finally, key takeaways, references. So measuring software design, right? We will walk through sometime later. We will walk through some real world code and some code from the various teams or people that volunteer to walk through it. Those are called dojos. We'll have them in the team. I think they make it fun. They make software development loads of fun. We'll do that for real world projects. But let's just cover the theory to start out with. This is a fairly crisp set of theory, not much to remember, right? But if once you have remembered them, right, it just changes the way you think. It just changes the way you work, right? That I've seen that from my own personal experience. So once you know that you're doing something wrong, right, there's obviously nobody wants to do something wrong. So getting that knowledge into your head, once you've gotten that knowledge into your head, you're redirected towards a kind of a more skilled level of right. And the skill is of course the part where you get into a situation where you feel that you have a command over a situation. So that's a lot of fun. And a lot of fun is also seeing that your skill is making your life so much more easier, right? So earlier something that you were struggling with, you had no idea. And now with the new set of skills, right, you can essentially just breeze through, right? So those are essentially the two fun parts of doing software development, in my opinion. Right. So how do you measure software design, right? There's essentially just 4 aspects to this. So the parameters are, right, so nameability, again, somebody else made it up, somebody famous, namely my mentor, Arlo, which is essentially just cohesion, right? So things that do similar things are sitting together, right? And cohesion basically means one and one thing. So you cannot name something unless that thing does some cohesive set of things. Like you guys must have seen things like XYZ utilities or ABC manager. Those are classic examples of where nameability is wrong, right? So so excuse the pun there, because I am a manager as well. But the whole idea is the moment you put a manager after something, right, then you know that that entity is doing a lot of random things. Well, not necessarily random things, but a lot of unrelated things, which is actually true from my experience as well as a day job. I do a fair bit of unrelated things. So nameability is this: unless you can name something, right? You should be able to, if something is doing one thing and one thing alone, it should be pretty easy to name it. Moment you put and, moment you put manager, moment you put utilities, right? That should be a flag. Testability. So there is no way you can test something if you have to test the entire world along with it, right? So then you'll get into some long range tests and tests that take like weeks to run and things like that, right? So the more decoupled something is, the more testable it becomes in isolation. And the more testable it is, the more you can guarantee it irrespective of everybody else. No duplication. Very dry, like super dry, right? And comprehensive set of unit tests. The reason the unit tests are required is that you don't know how things are going to change, and we'll cover that. But as they change, right, you want to keep a very close, very detailed, these are sort of like the patient is in the bed and you have a lot of leads and probes and you're observing every bit of the patient, right? So this is essentially for what your code is. I'm sort of, it's a bit odd analogy, but you get the idea. Right. Using this, right, you can essentially just say, hey, I want to assign 5 points to this, 5 points to this, 5 points to this, and 5 points to this. So you can actually just take a code review, say out of 20 points, how much is this code scoring? And then the deal with this is, right, you can actually get into an objective discussion with the person sending the code or whoever is the person giving you feedback, right? So this is much better than those stylistic discussions, right? And I have participated in them, I have given them, I have received them, where the tab, well, tab is a different topic, but the name doesn't look good and the alignment is not correct. The braces should be in this line. So some of those are required, but I think a more fruitful way to do is, getting straight to the point, right? So how do you improve your code, right? That's the whole purpose of code reviews and PR reviews. Now, this talk covers design at a component level. We'll come to other stuff. These are the outermost layers in the diagram, right? And then, of course, there's the functional programming patterns. This is pretty funky, but we'll come to this in due time, right? Now, design rot, right? So why and what, right? So can you guys take a guess why software rots?
Because the requirements are changing.
Yep. Yeah, because that's essentially the primary reason, right? Because the requirements change, and that's the law in the software world, right? Like the business changes. Business is very fluid. Right, today we're doing one thing, tomorrow there's a new set of customer either doing something new or wanting to repurpose in the fastest, right? The whole idea is that requirements change in a way that the design didn't anticipate, right? So and for good reason, right? You don't want to keep anticipating the future because humans are very bad at predicting the future, right? So you want to design for today, but you want to code for tomorrow, right? And this is all let you code for tomorrow. Related to that, changes need to be made quickly. So typically PM comes and says, hey, I want it yesterday, right? So that's typically the deadline we're all working with. Give it to me yesterday. And typically by someone who's not familiar with the original design philosophy, right? And someone here could be you 6 months down the line, right? So when you have forgotten, when the intimacy is lost, you'd really be wondering, what the heck did I do? What was I thinking? So clearly, someone doesn't necessarily mean somebody else. Of course, it could be, it mostly is, but it could very well be you. Right now, if this is the rule of the software game, right? If this is the name of the game, then we are better off just playing the game and not fighting it, right? And by fighting, I mean like, hey, don't touch this piece of code, and becoming very risk averse, becoming very change averse, right? Those things don't work out, right? At the end of the day, you have to do these things. This is what software is about. Are there signs of software rot? Can you objectively determine when the software is starting to rot? Yes, there are 7 clear signs of design and code rot, right? We'll come to this next. Feel free to interrupt me. The same challenge holds. So anyone challenging me, anybody just challenging the discussion, or even just bringing out something new points gets a lunch from me. And since Henrik is not here, on his behalf, I can say that last time he mentioned if you guys have any coding or testing work for him, he will top it up with beer. So keep that in mind. Okay, so the software design brought the smells. Right, this is a list of 7. It's pretty easy to get used to. Some of you will already have an intuitive feel for it because you've handled so much code that you know what it looks like. You know the stink, you know the stench. Right, what is this? So fragility. Right, the program breaks in many places with a small change, right? So this is what makes people very change averse, saying that, hey, you don't touch that code, I don't know what the side effect is. So anytime you sense a thought coming up in your head like this, or a teammate saying that, hey, you know what, I'm not sure, don't touch that, we are talking about fragility. Rigidity, right? So you're not able to change something without changing dependent modules and potentially 3 modules down the dependency chain, right? Which basically means that there's some decoupling or there's some solid principle that is in violation. Right, immobility. So you're seeing a very useful part, but it takes a string input, but you'd also wanted to take an int input. Let me just duplicate it, right? So that's a classic. I've been guilty of committing such sins. In my last year at Windows hypervisor, I actually copy pasted 5,000 lines of code simply because it did very similar things, but not the identical things. Yeah, my past is going to catch up with me someday. But the whole idea is that immobility here implies that you have some piece of code that is it will do the job, but you are not able to pull it out without putting in a lot of effort, and which is effort is of the size of the entire piece of work. So you essentially just do a copy paste, or you don't do the feature or whatever, right? It's a shame, really. Viscosity means drag, and viscosity comes in 2 forms. So software, sometimes it's easier to hack than to preserve the design. You know what, let me put a parameter in, and then put an if else case. So those instincts are indicating some sort of viscosity, right? And usually it goes 2 ways. So the less you change, the more viscous it becomes, even though you may be following the right principles. So one way to push that back is to push back on it. So just for the heck of it, sometimes just rename the variables, extract a method, so that's essentially what I do. Get into a system, obviously, with the permission of the team members, because you don't want them to find that the code is all different all of a sudden. But, the way to push back is to just build, kind of a bit of a mental, strength to just push back, saying that, hey, this code hasn't changed for a while. Let me just rename the variable. There's always something like that that has not been done. And something that's very easy, something that the tool can do, right? So very low risk as well. Environment. So environment insufficient. So I don't know anybody from the old Windows team here, the circa 2003. Do you guys know how long the XP build used to take? Windows XP. Anybody guess? Take a guess.
But we are all new to Microsoft here.
Okay, take a guess. Take a guess. How long the Windows XP build, Windows Server 2003 build used to take?
1 day.
Yeah, 1 day. 26 hours. Is it 2 hours more than 1 day? So the whole thing is, right, so for me to check something in and then go figure out that there is actually a break takes 26 hours. Right. So and then environment is like so super inefficient, right? And then the test process takes another 2 days. So by the time I get a bug filed on me, it's been 3 days since I made the commit. This is real deal. This is real stuff, right? So you can go look up in MS Web, and there are stories. I was part of a bunch of yeah, those are scary days. But nonetheless, there were some, they actually put Mark Lukowski, who was one of the technical fellows in charge to actually fix these problems, right? But we didn't solve this problem. We ended up creating hacks to work around this, right? So we created something called virtual build lab, and with deep hierarchies of, let's not relive those horror stories. But nonetheless, right? So the environment is so inefficient, build takes long, right? So any reasonable product build is taking more than 5 minutes. There's something wrong, right? It should be broken down. The test coverage, to get at least 80-90% test coverage, it should functional test coverage, it should take about maximum 5 minutes again. Right, so those are some of the things that we need to keep in mind, right? The reason is, right, if the environment is inefficient, then you'll think back, do I make this change, because I have to wait for this long, and then, so the environment is not supporting you, right? And then therefore you'll make lesser change. The lesser the change you make, the more these things will come into the picture. So it's like always a two-way battle, right? Then There is needless complexity. So constructs present that aren't currently useful, for example, deep hierarchies or configuration objects or parameters where we are not even checking. Dead code, for example, is a classic, right? So dead code is a problem with readability, right? All of a sudden I'm reading, and all of a sudden I have a block of code. I have no idea what it does, and I find out that, hey, you know what, this is not even compiling, right? But I dutifully make changes when I make changes, right? So this is like unnecessary. This is a sign of rot. Needless repetition. So the same pattern is repeating everywhere. Very subtly different pattern, right? Which means that anytime there's a bug, you have to go fix it at God knows how many places. And the deal is it's not the identical thing, because then you would have abstracted out a function, but it's subtly different, right? Right, parameter is different. Maybe just one line is different. I'm pretty sure we've all seen this kind of code, right? The final thing is opacity. So the module is difficult to understand, especially after intimacy has worn off, and difficult to understand not just for you, but not just for somebody else who hasn't worked on it, but also for you, right? So 6 months later, or not even 6 months, like 2 weeks down the line, when you go back, and it's like, what the F was I thinking, right? Writing this piece of code, right? And then those are the kind of reactions, like number of WTFs you have in your head is essentially means that the module is more opaque. Right, so these are some of the things that are. This is essentially the second law of entropy, second law of thermodynamics, entropy seeping in. These are the 7 classic signs of entropy seeping into the system, which means you have to fight back. Right. Right. So these are not an option, right? This will hit you, which means you might as well build the skills to handle this, right? So that's the way to look at it. Right. There's no point being scared of this thing, right? The more scared you get, the more these things will tend to build up. Right, so recap is this. Now, spotting the above during code reviews, PR reviews is an excellent way to build skills. So there are signs of this, and maybe some of us can make flashcards. And earlier in my earlier teams, I used to just have it in the walls, saying that, hey, fragility means this, example, this, so that when people used to walk in the walkway, it would hit them in the eye. Right? At least there'll be some part of it will get absorbed. So as a result, right, it was a fairly immersive environment. So it's a good way to learn it. That we can do some of that when we move to the office. But the whole idea is, right, when you're dealing with these kind of things in the code review, PR reviews, this is an excellent way to build skills, right? Because at the end of the day, this is what the job of a software engineer is, right? Churning out the best possible, simplest possible code that essentially meets your business requirements, right? PR discussions and CR discussions become objective and educational. Again, you're not fighting about tabs, new lines, stylistics. Some of them are required, not all of them are. I think tab is a very touchy topic. But some of these things, I think your time is well spent behind this, right? Definitely try these in code reviews and PR reviews, right? Right, and definitely trying, right? So somebody put a thing on Twitter, right? He said 1 line of 5 lines of code change, and the number of comments I have is 15 or 20. 1,500 line of code change looks good. Right, so instead of doing all of that, right, you can just, these are some of the things we can start drilling down, right? So no longer the code becomes an opaque blob of something that you're reviewing, right? You can immediately start spotting patterns like this. Now, design tenets, dry and Yagni, right? How many people have heard of dry and Yagni? Anybody? Nobody? Okay. So Yagni is, you're not going to need it. Again, I didn't make this up. Somebody famous made this up, and it's very applicable. And this is a part of a normal lingo, software development lingo, the modern lingo. And dry is do not repeat yourself, right? Typically, right, anytime you're underdoing solid, like you have postponed a solid pattern for a long time, you will be committing some kind of dry violation, right? You can check it up, right? And if you're overdoing something, that means you're violating Yagni, right? So this is typically the way to think about how this relates to this thing, right? So this is something that I think we've discussed already, right? So you mess up, you detect, you diagnose, and you repair. Right? This is the solid loop, right? And this is the law of software, right? And this is, you continuously mess it up because you're under time pressure. Things change, but then you also have to detect and diagnose, right? Otherwise, your entropy is going to just keep increasing. This is a way to sort of bring down entropy. Yagni, the deal is essentially what you can do versus what you need to do, right? This is what the deal is, right? Coding is a nice thing, but remember our job is not to code here, right? Our job is to solve business problems. And code is one of the ways to do it. You can also buy a company. You can also employ an outsourcing department. There are multiple ways to get the job done, right? Typically, coding is the costliest way to get job done. Way to get a job done, right? So this is where you need to be very careful about, right? So do you want to churn out reams and reams of code, or you want to churn out the sufficient amount of code, right? Everything falls in the scope of Yagni. No holes barred. Again, there is a star there, right? What does Yagni prevent? These are some of the things to know, right? Scope creep. So scope creep means, hey, I got to do this and I got to do this as well, and I got to do that as well. And all of a sudden your backlog is full of things that sort of you need to do, but you're not sure you should do, and you probably don't need to do, that kind of stuff. Priority inversion. An example of priority inversion is, hey, I want to get this change in. This change requires the other change, and the other change requires the other change. So therefore, I can't do this change till I finish the two changes. So all of a sudden, the things that are not even in the priority are just, 1 and 2 in the priority order. So that's priority inversion. Typically, there you can use the Yagni thing and just cut it through, saying that, hey, you know what, we'll deal with it later. It's more effective when you get into the team vocabulary. So if somebody is starting to over design, right, and it could be it could be me as well, right? So when you guys see me doing over designing, right, hey, Yagni is a good way to challenge it. You can just say Yagni, right? You don't need it, right? And your teammate will be forced to explain to you why this cannot be Yagni, right? So what's a caveat, right? So can you always Yagni? Short answer is yes, but of course, right? Every rule is an exception. Remember that architecture, another alternate definition, is the art of making choices that are expensive to change down the line, right? So think of your house, right? You could technically start out by building wall after wall, but that's not what they typically do, right? The age-old wisdom is to put beams and pillars first, because those are the things that are hardest to change down the line. You can just quickly break a wall and remodel your house, but anytime you have to break a beam or break this thing, right, then it becomes more expensive. You'll probably have to move out, and that's the idea. What are examples? So beams and columns of your house. Another example is security in a banking software. So if somebody is going to call Yagni on the security aspect of banking software, you have a lot to lose. So you typically want to rule out security straight away. Rule out as in have a good secure platform right away, right? So now you can always call Yagni, but Yagni is not the same as laziness, right? And here's an example that case study, right? So this was one of the first times that I was essentially taking the team through this. So this is the first time we were learning this. So one of the principal SDs in the team, right? So he was in charge of putting up a design for something called the load test service, and this is a money earning service. This is scheduled to be a money earning service for Microsoft, right? Fair bit of money as part of the ALM suite, right? So the whole idea is that the load test was working on online on-prem, and the job was to take it to online so that people can program it over the internet. And load test, essentially you just program a REST API and it fires in a rapid succession, say a load of 500 million APIs at one shot. So the call there was, right, and this is one of the how not to do things. The call there was, why don't we just take the on-prem box and lift and shift to the cloud, which is basically have a VM in the cloud and put the SQL server there, put the compute there, put everything there as a VM, right? So we asked him for a way to explain his design, and his call was, hey, this is Yagni. But you've lost the point there, because the whole purpose of making a cloud load test is the cloud there. So you have to design it in the cloud programming model. So it's so it has you're able to auto scale it. You're able to use SQL Server on the managed SQL servers to bring down your costs. So the SQL Server maintenance is done by Azure, and those are the aspects, right? So the whole point of this was cloud load test service, right? But then I guess we were all learning new this, and then he made the call, and so this is where, right, it's that instance was an example of laziness. That was not a instance of Yagni. The right thing to do there would have been to say that, hey, you know what, this is the way we go forward. This is the way we add things in slowly, right? But for now, for the prototype purpose, I can just run it as a lift and shift, right? So that's just a case study of what not to do and where case study of abusing Yagni. Dry. So this is arguably the root of all evil in software, right? So every pattern, every framework, every operating system, every reusable piece of software that you see is result of solving some form of dry, right? What's the problem with dry? It creates dependencies and therefore coupling, right? And dependency means, what, this looks like this, but it is this, but then I have to remember 5 days later that these two are related. You get the idea. This is an excellent talk. Definitely watch it. It's not all that dry. He makes it a lot of funny, right? But take a look at this, right? He presents it in a very structured manner. The whole idea is, right, for you to duplicate something, you have to do it at least twice, right? So don't, right? So once bitten, twice dry is the mantra. Making things dry is how, pretty much. So operating system is somebody decided to say, you know what, I'll abstract away the graphics aspect of it, the CRT aspect of it. So you guys can all call into my service, which is how the OSs are born, which is how React, Angular, which is how your libraries, right? Whatever you call it. Generics is a classic example, right? So code that looks similar for int and string, a sort program, right? Doesn't really need to be different. So you can push in, .NET generics. Design patterns, they're all coming into existence because of dry. So if you're committing dry violation, there is an abstraction waiting to come out. Now the kinds of repetition could be just code. It could be structural. It could be test code. It could be fixture in test code data. Like there are various number of ways of committing dry. Right. What's the caveat? So the caveat is, should you dry things up always? Yes. Unequivocally, yes. Right. But again, this is the real world. So duplication means you have to do it at least twice. So don't start predicting that you will duplicate. So then you will go wrong for sure, because humans have a long history of proving that they are bad at predicting the future. So ideally, at the second time you have duplicate and checked in the code, as the next instance, refactor it and make it dry. But if not, at least by the third instance, when you start on the third instance, so the third instance of repeating something, make it dry, right? Otherwise, you're just building technical debt, right? The other counter example that I've seen is something called wet, right? Explicit tests. Again, I didn't make this up. Somebody famous made this up, and this is very applicable. It's preferable to keep the unit tests explicit instead of building, massive test hierarchies like test base, test module utilities, and blah 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 blah. You just keep it simple, boom boom boom, and it's done. All right. So write explicit, and this might require a little bit of duplication, which is okay. Right. I think we're pretty much done with this talk. So now there's this concept of merciless refactoring, right? And this is what is the thing about pushing back against the law of second law of thermodynamics as applied to software, right? So entropy keeps increasing, disorder keeps increasing. So then you do something called a merciless refactoring, and merciless as in you don't have any attachment to the style that the code was written, or the style or the pattern that you wrote the code in. You don't think it is useful, or just for the heck of it, you change it, right? Obviously, with make sure that you have approval of your team, the immediate team, because they are also equal partners in it. But the whole idea is you get together and kind of just change the shape. This is a good way to kind of build your like fight back against your inherent fear of change, right? So, and the more you fight back, right, the more the lesser fear you tend to build, right? This is something that I've seen again and again, right? Just go into the system, for the heck of it, change the variable name, right? It's pretty cheap. So merciless refactoring is one of the core principles, one of the 4 core principles of extreme programming, right? Then this is one of the pillars there. The whole idea is that why code rots, entropy increases, need to compensate for this. This is a way to compensate. The way you do it is detect with engineering practices, with your continuous delivery pipeline, CI/CD, with your pair programming, with PR reviews and things like that. Diagnose, you have a set of tools to diagnose what it is, set of principles to diagnose, and you repair it, right? So repairing essentially just these 3 things, right? This will essentially help repurpose existing code to serve new business requirements, right? Which is what we are in for. Right? This is where the fun is, right? Writing code that serves new customers, new businesses, and making your business earn a lot of money, right? This is where the kick. This is what we get a kick out of. Right. The more you do this, lesser you get scared of the code base. So that this fear is real, the fear of change, right? Again, start small, change variable names, extract functions, reorder parameters. These are very cheap. These are very low risk simply because the tool will let you do it. Control R is just, I forgot, control R is a rename. It's a finger memory thing, right? Control R, control M is extract the method, things like that, right? And I think if you guys want resharper, right, this is something that I think most teams in Microsoft, there's no reason why we shouldn't. I have to talk to Enric, but I think we'll have budget for this, bringing in resharper and, using resharper in our day-to-day work, resharper and the JetBrain tools, right? So this helps a lot. Refactoring spree is essentially when 3-4 of us get together, maybe on a Friday afternoon, we are feeling bored and we've had enough of work for the rest of the week. And I say, hey, this piece of code doesn't look right. And here are all the smells. This really does work. This really brings the social aspect of coding, right? This really is a way to have a lot of fun, really lot of fun, right? And at the same time, you are, you're building your skills, right? This is repetition, right? So Friday evening, right, or not evening really, but Friday morning, you've had enough of work. You've whatever it is, fine. You met your schedule, haven't met your schedule. Hopefully not for too long, but the whole idea is you just get together with a few friends and say, hey, I want to break this code up and refactor it, and then just go to you essentially do a merciless refactoring, right? No mercy. Again, this will require a balanced set of developer tests. Good automation in terms of not only tools but an engineering pipeline. The stronger your engineering pipeline is, the more confident you're going to be. So if you have a piece of code and if you have a product that has 0 tests, right, and it's all related, all based on manual tests, obviously you're going to get scared of refactoring. But if you have a pipeline that in an automation runs pre-check-in tests, runs post-check-in tests, runs validations, performance, back compat tests, and does some level of acceptance tests in the dev environment, right? Then you can just see a change go through, right? And if there's a problem with it, then it will tell you back, right? So these are some of the things I have done in the past, and these are like really this makes it a lot of fun to work in the in the pipeline. Anyway, getting back to the key takeaways, I think we're done with this. Make PR code review discussions objective and actionable using the following, right? Scoring code and test quality using the 4 points: nameable, testable, dry, and unit tests. They are really the 4 points. Right, the 7 code and design smells. So I have a personal mnemonic for this, but you guys will have to invent your own. Right, and these are related to some teams that I worked in, and blah, it's a complicated mnemonic, but it just sticks. Ruthless Yagni. Ruthless Yagni is a real term, right? Everything is in the scope of Yagni, right? You're keeping your code base dry and do merciless refactoring. References are these, and I think we're done. Somebody has a question. Go ahead, Max.
Yeah, I'm sorry. I just wanted to pick that up as you were also mentioning ReSharper. I think this is a great topic to discuss because I know there's nowadays quite a few of pushback. Like if you have ReSharper, you get a Microsoft confidential notification at least twice a day, which tells you to please uninstall this again and try out the new Visual Studio because this had all the features that ReSharper has. So just sharing some experience after I installed it. It is quite a bit of pushback, and you get some mails from the Visual Studio team asking you to share your feedback and uninstall it, basically.
Yeah, we should talk through this. I think there is some bit of obviously Visual Studio team wants their product to be used, and I have seen in the past, right? This can tend into. We'll have to take this carefully. I don't think the Visual Studio is as good as ReSharper. Absolutely not. Does it mean that we use Visual Sharper and give them feedback once in a while? Sure, they are the company product, right? But I think this is. I think we need to. Let's talk about it. I'm happy to. I do not think Visual Studio is as good as ReSharper. And anything that is a productivity hit, we should be fearless to put it in our daily this thing, right? And there's a pushback from the Visual Studio team. I can help. I can go talk to them. They'll probably be friends of mine. But yeah, I think this is a good point to bring it up, Max. Right? Let me know how I can help you guys on this. Right? Yeah, let's take it forward. Hey, Radhik.
Hi, Parfa. I wanted to just talk briefly about the dry. If you can maybe open that slide again.
Sure can.
The last one of the dry.
This one?
Yeah, this one.
Yeah.
Because here you said, should you always dry things up? Yes. And I think you said that you will have like a domain-driven design presentation coming up later on. Because one of the things regarding the dry that at least I know about is like you shouldn't always dry things up in microservices oriented architecture, because you sometimes introduce a new element, right? Like, okay, we have it in all of our microservices. How about we create a new microservice, which now all of these other microservices depend upon, and you now have a distributed monolith. And then they say, okay, but if the microservices are well defined, even if there is some type of redundancy, well, how about you actually don't try? Just, yes, do repeat yourself in each of the microservices as long as they are properly bounded to a single context, right? And sometimes it's like a hard lesson for people who are always told, don't always follow the dry, and then you go into microservices and people start telling you, no, it's actually okay if you repeat the very same code, or it's like almost the same, because introducing a new coupling is actually making it all of a sudden a distributed monolith. And I wanted to kind of ask you, am I thinking right here, and what's your take on what I just said?
Yeah, I think that is correct, right? Like no need of transforming that into a distributed monolith, right? So that's absolutely right? So you want the entire system, entire orchestra to work in spite of a couple of services going down, right? So that's absolutely true, right? However, I think the other aspect is also true, because if we have investigated all the ways of making things, like here, reducing of duplication could very well mean having a version library for the common things. So you could technically take those common things and wrap them up in a version library, and each team can pick some version of that. Each service can pick some version. So that could potentially be a way, right? So the only thing that I would recommend here is that we take a closer look at the ways we have tried to do dry things up, and there are multiple ways to removing dries, right? And then if nothing else works, right, and if it goes towards the direction of distributed monolith, then definitely don't do it. Right, but my recommendation would always be like, what are the steps we have gone through to see how we can consolidate some of those things?
Oh, sure. And if we are, for example, talking about library or a NuGet package that now you manage and everyone can hook up to a different version, fully agree. Is
Correct.
that sometimes it's like if you have two bounded contexts and it just happens that
Yes.
some of the things overlap between the two of them,
Yes.
Don't force people to going dry over there. Just actually repeat a little bit of each of those. And yes, the team will need to handle it in both cases. But like now they are really independent, and maybe one day down the road, you will make them a little bit different, right? So that redundancy is not always a bad thing, I would say, as long as you have properly defined contexts, bounded contexts.
In the case of the distributed services, I agree with you. Yes, that is definitely, some cases, some of the domain objects you can definitely repeat, right? There's no need of artificially saying that, hey, just because one line of code or one class or one data carrier object I've defined, you have to have a separate packet for it. Absolutely, I agree with it.
Okay, nice, thanks.
Thanks, Radhik. The next talk will be from Thomas, so you guys will have a break. I can promise two things at the end of this set of talks, right? One is people will get shit bored of me, and second thing is people will fall in love with software all over again. And again, and again. All right, I think we can call it a evening.
Thanks, Partha.
Thanks a lot, guys.
Thank you so much for this talk. Great talk.
Bye-bye.
Thank you, guys. Bye.
Thanks, Partha.
Thank you.
Thank you. Bye-bye.